Hello and welcome back to more Pygame. Downloaded this asset pack here, Sprite Lands. I'll leave the link in the description. They have a free version. You can download a free version and play around with it. But it's not very expensive, $3.99. So I'd recommend support the artist and buy it. Now let's see if we can get this working in a Pygame. So they've got this cute little cat thing that can be our character. So by the way, if you're going to follow along with this video, I've got the paid version, but I'm just using the cut down basic character sprite sheet. So if you only get the free version, you should still be able to follow along. And what we're going to do is we're going to grab this sprite sheet here and see if we can animate this little character. So it's kind of small, but here's the cat. You've got the top row here is the down animation, second row is the up animation, and left and right. So let's see if we can get this. First of all, let's just see if we can get this image on the screen, and then we'll see if we can animate it with the different directions. So to make things easier, I've put together some boilerplate code for getting our Pygame started. This is an object-oriented version, so we're using a game class, sets everything up. So if you've seen my quick start tutorial, or if you've been through the Pygame quick start, then you'd kind of know what all these things do. This is just putting it into a class here. So yeah, the main game class, we've got our init function to get everything set up. Then we've split out different functions to handle events, update, draw, and run the game. Then we've got our little main if statement here to see if we're running it as a script, and then it will just start the game, create a game object, and then run it. So again, I'll chuck this link in the description. Feel free to use that as a getting started boilerplate. So I've already done that. I've created a file here, pasted that in. Let's just change this one thing here. So set the caption instead of my game. Let's call this sprites animation. Okay. Just to make sure everything is set up okay, let's run it, and there we go. We've got a little caption there, and our screen with a cool gray background, but it doesn't actually do anything yet. Okay, so what we want to do is get an image on the screen. Now I have this sprite sheet here, but let me just grab a copy of that, and I'm gonna have to chuck it in here. So let's create a new folder, and we'll call it assets. Paste this in, and I'm just going to rename it to make it easier. So I'm going to call it character. No, let's call it player sprite sheet, and that's a PNG file. So let's try load it and get it on the screen. So here in the documentation, we have this image load function. So this is what we can use to load the sprite sheet. So load an image from a file source. You can pass either a file name, a Python file-like object, or a pathlib path. Pygame will automatically determine the image type and create a new surface object from the data. In some cases, you will need to know the file extension. If you pass a raw file-like object, you may also want to pass in the original file name. The return surface will contain the same color format, color key, and alpha transparency as the file it came from. You often want to call pygame.surface.convert with no arguments to create a copy that will draw more quickly on the screen. For alpha transparency, like in PNG images, that's the one we have, use the pygame.surface.convert alpha function method. Sorry. After loading, so the image has per pixel transparency. Okay, that's what we want. So, okay. So yeah, what we want to do is Pygame image load, and then we want to use this convert alpha so that we can have the transparency here around the character. So let's just try to load it first of all. So we should probably create a new class for our player as well. So let's just say class player. Yeah. And then what do we want to do? I guess we kind of need to know the sprite sheet. So that we can load that. Yeah. All right. So let's use this Pygame image load. So sprite sheet equals Pygame image load, and then actually let's change that to so the sprite sheet property of the player will load in the sprite sheet. So this is going to be a bit confusing, but when we create the player object, we're going to pass in the location of the sprite sheet here. And then we'll load it and store it as this sprite sheet property of the class. Hopefully you guys have a bit of a background in object-oriented programming. I'll try to explain things as we go. But yeah, I mean, we're not going to go too deep, so it should be fine. Right, and then we need to do this convert alpha. Convert alpha. Okay. Constants here. Let's just add another one. Player sprite sheet. And let's just grab the location of that. So it's going to be in our assets player sprite sheet PNG. I think that's what we called it. Let's just take a look. Whoa. I do that a lot. So here we have our assets and player sprite sheet.png. So that's in the right place, named correctly. Cool. Now let's create the player here. So in our main game class, let's create a new player, and we'll pass in the player sprite sheet. So here, when we initialize the game class, which we do when we run the program, we create the game object, it initializes the class, and it will create this player object here from this player class. We're passing in the player sprite sheet that we've defined in the constant here. And then when this object is initialized, we set the sprite sheet property of this class to be to load this image sprite sheet here and do the convert alpha. Let's see how we go so far. If we run this, it does that and does nothing. So I mean, hopefully it's running fine. Hopefully we'd get an error if something has messed up so far. But we kind of don't know. We kind of don't know until we actually try to draw the image on the screen. So in Pygame, that's called blit. You blit the image on there. So blit source, destination, and so on. So yeah, so that draws a source surface onto this surface. The draw can be positioned with the dest argument. The dest argument can either be a pair of coordinates. So this is important. We're gonna have to tell it where to put it. Um, um, and where is it? A pair of coordinates representing the position of the upper left corner of the blit, the upper left corner. So if we have this image file here, it's going to be the upper left of the image. Okay. The size of the destination rectangle does not affect the blit. What is area then? Um, uh, where's area? Area. Okay. An optional area rectangle can be passed as well. This represents a smaller portion of the source surface to draw. Okay, now this is interesting because this is what we're going to have to make use of in the future. So you see here, this sprite sheet, it's got every part of the animation. So every frame of the animation, whether it's down or up or whatever. Um, Most of the time, well, all of the time, we're only going to show one frame, right? We don't want to show this whole sprite sheet because that's not a good character. We want to show just one frame and then animate through them as we move through the world. We'll do that part later. Let's just get this on the screen first of all, but this is good to know. So area, that's something we're going to have to pass in to draw this thing properly. Special flags, optional. I don't know what any of that means, so I'm going to ignore it. Okay, so let's try and blit this thing. So blit is where is the example? Um, okay, Pygame surface blit. So um, let's just try and blit the blit the sprite sheet we have. So here so I think before we flip the display, but after we've filled the screen, we want to blit the player. So what's this going to be? Player, yeah, self player spreadsheet. Where'd we go? Self player sprite sheet blit. Is that going to work? I don't know. Let's see. This is possibly kind of messy. I don't know if this is the best way we should do it. Maybe we'll refactor it after. Let's just try and get something on the screen. Oh, okay, it died. Of course, we didn't pass in missing argument source. Okay. Um, where's our blit? The source draws a source. Okay, maybe I'm doing this wrong. Um, maybe maybe this is the source. The sprite sheet is the source. But Pygame display blit. But that's what we pass in. Okay, that didn't work either. Pygame display. Okay. Surface. So which one is the surface? I thought the surface is what we would. Is screen is the surface maybe? Self screen lit. function missing required argument dest in our. Okay, yes. So blitz. We need to give it the destination. So we need to give it the coordinates of where to actually blit it. So we're making progress. We're getting there. Do not despair. We just need to give it some coordinates. So I'm hoping we can just give it a tuple, and let's just say 0, 0. That's going to be the upper left corner of the screen. We did it. We did it. Yes, look at this. We have an image there. We have our little sprite sheet is showing in the upper left corner. Okay, we made it. So we've got this here in the top left. Let's see if we can get only one showing instead of the whole sprite sheet. So we did have, going back, we had this area thing here. So the area rectangle can be passed as well. This represents a smaller portion of the source surface to draw. So I think that's what we want. We just want a smaller portion of it. So this sprite sheet here, how big is it? 192 by 192. So 192, and then it's a 4 by 4 grid. So let's divide that by 4. So 48. 48 by 48 is the kind of area that we want to show each frame. So let's close that. So for our player, gonna have, I don't know, frame width and frame height equals 48. Now let's create. This might help to tidy things up a bit. Let's create a our own draw function here for the player, and then this is where we can do the player draw. So it looks like we're gonna have to pass in the screen. But we can do self.player draw and then pass in self screen. And then here, that's where we can split. But yeah, we've got the screen passed in now. Okay, let's make sure that still works. No. Cannot unpack uniterable uniterable why did that die? Self player object has no attribute player. That's right. Because it's the sprite sheet. This is the player already. Okay, there we go. So we're back to square one, but with a bit more structure, sort of. Was it worth it? I don't know. Okay, so now let's see if we can just output one frame instead of the entire thing. So based on this documentation, it looks like we need to pass in a rectangle. So Pygame rect. Left, top, width, height. Okay, it literally is just passing in all 4 coordinates of the rectangle. Okay, so let's try that then. So self rect equals new Pygame rect, and then let's just give it 0. So I think for Pygame, I think it starts 0, 0 is at the top, right? So then we'll start off as 0, 0. So the first coordinate, where where is the documentation? Left top width height. Okay. So left. Okay, so left, I'm guessing that's like here. Left top width height. I don't know. Let's try. Okay, let's try 0, 0. We'll work this out based on our coordinates. So we know we got 48 by 48 is the frame we want. So I mean, yeah, width and height should be 48 and 48. I'm guessing, and then left and top. Let's just make it 0, 0 to get the first one here. Let's see if that's correct. So 0, 0, and then we've got our constants here. So let's go frame width and frame height. Okay, so that's our rectangle. And then when we blit it, where's blit? That's where we pass in the area. So can we just pass in the where was it? Yeah, source, destination, area. Source, it's the sprite sheet, destination right at the top of the screen, and area is our rect that we've just created. Let's see if that works. It does. Look, okay, there's our character there. That is the first frame of the animation. If we want to go up, and let's get this one here. I'm guessing we'll just go down 48 on the top. Let's see if that's correct. Sorry, need to close this. So trying to get the top. So let me put these in for where are we? Rectangle, left top width height. So left, oops, left top width and height. That's just going to make it easier to see what we're doing here. So okay, so if we want to get this one here instead, I'm guessing we go down 48 from the top, or down 48, but actually we're adding 48 because this starts at 0, 0. So 0 plus 48 to get here. So top, let's go 48. Oh, okay. What have we done wrong? Argument must be rect style object. Okay, maybe we can't use those names. I'm gonna add it as a comment above then. How do you do a comment in Python? This one, I think. So rect. Okay, so 0, 48 frame width, and then the frame height. Okay, that's better. And looks like it works. It looks like we're getting the right one. Sorry, I know this is really small. It's it's a tiny little sprite here. Okay, good. So we go yeah, 48 that way to get that one. So this is how we're going to get through all of these is by multiplying by 48. Then the other way as well. So we can I mean, let's try get that one too. Oops, I shouldn't have closed that because that's going to be a useful reference. So we'll try get this one. It's very, very hard to see. I don't know if you guys are going to see it on the video. Actually, let's go two across then. So we can get this one here because that's a little bit more obvious. You can see he's got his stride there with his little paw up. So if we go back to our code, so this one will put back to 0. But here, let's have frame width times 2. So that should be this one here. Okay. Whoops. I think we've got the right one. Yeah. Yep. So we're getting that one there. Okay. Good. This is good progress. So this shows that with a little bit of multiplication of the frame width and the frame height, which are both the same coincidentally, we can get the right frame that we want. So I guess we're just going to have to work out which frame we should be getting. So we're going to have to know what direction the character's facing, so that we know whether to be up, down, left, right. And we're also going to need to know, well, we're gonna have to animate it. So every frame we're going to have to change it. So yeah, we're gonna have to do that. So the easier of the two, I think, is going to be the direction. So direction here is down for the first row. But let's go based on indexes, right? An index of a list or an array or whatever. So 0 down, 1 up, 2 left, and 3 right. So here let's give it. Okay, so we're gonna have to have we're going to have to know the player direction. So self direction equals, let's just start off with left. Actually, no, sorry, let's start off with right. Okay, right. Sorry. Okay, so the direction, yeah, the direction is right, but we can give this, yeah, I mean, do we need to make it clearer? I think this should be fine. We can create a dictionary here. So up. Wait, what was the first one? No, down was the first one. Sorry. So down, up, left, right. I don't know if I don't know if a dictionary really is the best for this. When we could just use a list, but at least this makes it really, really clear. So if we set the direction of the player as right, then that's going to be row 3 or row 4. But when it comes to the index, it's 0, 1, 2, 3. So we should be able to, when we draw this, we draw it out. We kind of need to have an update function here as well. Update method, sorry. So here, this is where we'll update the rectangle to show the right frame. So in our game, when the game is being updated, we'll also update the player. So self player update. I don't think we need to pass anything in right now. So depending on the direction, can I chuck this on a new line? Because I think that's going to make this a bit clearer. Okay, so okay, so when we're creating the rectangle, the left one here, actually, oh, this is good because then I can just add the comments here. Okay, so the left, the top one here, how far we go down is going to depend on the direction. So if we're going down, we don't, that stays at 0 because the top is right here. If we're going up, then that will be 48 because we go 48 pixels down here to the next frame, and so on. So we can times this by the frame height depending on the direction. So this one here is going to be the self directions, and then we'll pass in the current direction that it is. So if we're going right, it'll look up this one here and then pick 3. And then we just need to times that by the frame height. Okay, let's chuck this back to 0 for now and make sure that we get what we're expecting. So right now we've just hard coded the direction of the player to be right. So that's that one there, which is 3 times the frame height. So let's see if we get that first of all. Okay, yes, looks like that's working. So again, sorry, it's very, very small, very, very hard to see. But yes, we're getting that one there. So that's good. Let's just do a quick test and change the direction to let's change the direction to left. And yeah, now we see that the character's heading left. So we've got direction working properly, which is good. We could now do a check for the keys to see if what key is pressed to change the direction. I think that's probably a good thing to add next because then we can see that updating. So let's just by default have the character facing down So it kind of starts off like that in the idle animation when everything's initialized. But let's get the input from the keys and then change the direction based on that. Okay, so in our game class here, we have this handle events function. Um, let's add one to the player as well. So self player handle events. And then we can add that here, just so that our player class kind of mirrors the game class. So handle events self. Okay, so what we want to do is we want to get the keys pressed. So yeah, every time it goes through here, our player handle events will be called. So in the documentation we have key get pressed. So get the state of all keyboard functions. So returns a sequence of Boolean values representing the state of each key. So what we want to do is we kind of want to get the key down. So Pygame key get pressed. Yeah, okay, keys. I guess we kind of need to know what they are. Can I just print these out and see in the console what they are? False, 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 false. Okay. Uh, that's that's not going to be helpful. Okay. Um, okay. Yeah, let me clear that away. Yeah, that's not going to be helpful. We kind of need to know what those mappings are. Is there not anything in the documentation? Get pressed. Oh, are they here somewhere? Yes. Okay, good, good, good. Here they are. Here they are. Okay. Right. So, up arrow. Do we want to use up arrow? No, I think we want to use the WASD. Um, so yeah, K underscore and then it's going to be WASD. All right. So I think let's change this to pressed. And if pressed, and then I think it's going to be the what is it? K underscore. Um, let's look for the W one because that's going to be up first. So we'll look for up. So if pressed if the W key is pressed, then self player no, sorry, self direction equals up. Okay, let's see. KW is not defined. Ah, whoops. Sorry, this is gonna be the string to look that up. So you need to wrap that in quotes. String object can be. Okay, so it's a string object cannot be interpreted as an integer. Okay, so it's not a string. It is not a string. It is a constant. Okay. So okay, yep. So Pygame nicely has created these as constants already. So this one is just going to be accessible this way. Okay, that's better. Okay, so facing down at the moment, if we push the W key, it should go facing up. And it does. Good, good. Obviously we haven't written in any of the other keys, so it's not going to move any more than that. But now that we have now that we know how to do it with the syntax here, then we can look for the other conditions. So pressed Pygame K S. Do we need? We don't need these in Python, do we? Self direction equals down. Let me just make sure. Okay, yeah, no, we don't. We don't. Okay, good. So, yep, up, down, working. Okay, I'll just do the rest. Okay, so up, down, left, right, up, down, left, right. We've got our character moving. Yay! The character can change direction. That's good. That's the first part of it. So the top is working. Okay, so animating the character. Essentially, what we need to do is we need to keep track of what frame we're on, and there's only 4 frames, right? So let me bring up the sprite sheet again so we can see. So assets, player sprite sheet. So there's only 4 frames, right? Because we've got different directions, down, up, left, right, and there's 4 frames for each of those directions. So really, we just need to keep track of 0, 1, 2, 3, and that way we can loop through them. Now we are working with a game loop, so every update, every frame, this update function is called. So we could start off by first of all, we could start off by just going through each frame every update. It's going to be super fast, but we could start off by doing that. Let's check that out um, and see just how that looks. So thing is though, we're also going to have to keep track of a variable for this. So let's call it frame. And we'll start off with that being 0. So self frame equals 0. And similarly to the direction, we need to multiply it by, in this case, the frame width. Right. So so every update, we're going to have to change that. So right now it's not going to move at all because it's always going to be set to 0. But what we need to do is after we've set that, then we need to animate it. Sorry, increment it. So self.frame, I think if we do it afterwards, self.frame equals, can we just do like plus equals 1? Yeah, does that work in Python? I think so. Python main py. No module found Pygame. Oh, sorry. Yeah. I went off for a break and I haven't activated the virtual environment. There we go. All right. So it looks like we have nothing being displayed there, which is kind of strange. Let's take out this part for now. And make sure that it's working. Oh, okay. Sorry. of course we're getting 0 because this is 0. So anything times by 0 is 0. So we're going to have to do it up here. Yes. There's problems with this, but let's. Oh, that's not valid syntax. Okay. Sorry, maybe we can't do that. Okay, so self.frame equals self.frame plus 1. Okay, let's make sure though that we're just containing that. Okay. Expression cannot contain assignment. So okay, I guess we have to do it beforehand. So self.frame equals self.frame plus 1. Yeah, of course we can't do that. So yeah, okay. So we update the frame here. And then here we'll multiply it by the frame width. We still get nothing. Why is that? Let's do some debugging. So print self frame. Let's see what we're getting in there. Okay, so okay. I mean, we're going way too far. Right. Okay. Yeah. So I mean, this isn't even on the sprite sheet. The sprite sheet only goes up to what 192 or whatever it was. So yeah, we get past that very quickly. I'm guessing at the start, yeah, it'd show the first 4 frames very quickly, but then it would very, very quickly be off the screen. So I think what we want to do, seeing as though we've only got 4 frames, if we use the modulo, then we'll only make sure that we get up to 4, and once we get to 4, we'll start from 0 again. So yeah, okay, that's better. It's moving super fast. But it's at least animating the way we expect. Now, let me just remove the debug because that is, sorry, the print statement, because that is giving me a headache. But okay, so yeah, so our directions still work as well, which is nice. It's just really fast. So we're going to have to adjust for that. So something we're going to have to do, as well as the frame width and height, we're going to have to keep track of how long we want the frame to be shown for. Frame duration, I guess. And this is in milliseconds. Let's start off with 100. I'll just put a milliseconds. Yeah, so we'll keep track of how long a frame should be shown for, and then we'll keep track of how long it's been since the last frame. This is our delta time. So I've tried to explain this in a previous video, and I failed miserably. So hopefully you know what delta time means. Basically, it is the time since the last frame has happened. It's going to be different on all computers. All devices might be running at different speeds. So we kind of keep track of the time independently. So here we can say, okay, we want a frame to be shown for 100 milliseconds, and then we'll show the next frame. So we can keep track of that there. So then obviously in the update method for our player, we're going to have to um, we're gonna have to keep track of that time. So okay. So this is us saying this is what we want, but we're gonna have to make a timer to be able to keep track of what the reality is. So we want it to be 100 milliseconds, but we're gonna have to have some kind of counter to see like how long has it actually been. So in order to do that, I mean, first of all, when we start off, um, it's going to have to be 0. So let's call it animation timer and set that to 0. Okay, so now the class is initialized, the game loop starts, and we need to start counting um, how long it's been, right? But in order to do that, we kind of need to know the delta time. We need to know since the previous frame, how long has it been? And we can do that, but we need to do that in the game class. I mean, we don't have to do it in the game class, but it makes sense to do it there because it's going to be used throughout the program. This delta time is used a lot in games. So we're going to use it later for movement. When things are moving around, we want to adjust it based on delta time rather than frames. Um, so we're going to use it a lot. So I'll chuck it in here. Now, so we're gonna have to create a variable. I'm thinking, um, yeah, I'm thinking we create the variable. I'm thinking we just create it and then, hmm. Okay, let's create a global variable. Um, delta time equals 0. Um, so actually, no, that's not going to work. Let's for now, let's just create delta time here, um, and um, and then um, we can pass it into the different places where we need it. Um, so um, okay, delta time. Okay, so we use this here. So this self clock tick. Um, um, and so we can kind of do it at the same time. Um, so delta time equals self clock tick, and we'll divide it by 1,000 to get milliseconds. So yeah, all right. So now we have the delta time. Actually, ooh, we kind of need to do this first, um, because we're going to need it for these things here. So we'll grab the delta time and then we'll handle events. Um, where are we going to need it though? Handle events, player, handle events. We'll probably need it there later, but for now we really just need it here in the update. So updates, let's pass in delta time. And then for this update function here in the game class, we also need to, whoops, I undid that. So we also need to pass the delta time to the player update function as well. So actually, sorry, here let me just make sure that we're accepting delta time in that update function, and then for the player as well, delta time. Okay, so now that we have that, this is where we need to start incrementing the animation timer. So the first sort of thing that we can do here in the update function is animation self.animation timer. Now plus equals, I think that's what I was missing before. So here we're going to use the delta time and times that by 1,000. Do we times it by 1,000 again? Here we're dividing by 1,000. Yeah, we may not need to. It may already be in milliseconds. So let's do that. Delta time. Yeah, let's see if we need to or not. So essentially what we're doing is we're just adding the delta time to the animation timer. So we're essentially incrementing the delta time. Now, if the self animation timer is greater than or equal to the frame duration, this 100 milliseconds, frame duration, then in that case, we want to start again from 0 and increment the frame. So self.animation timer, sorry, typo there, equals 0. So we reset the timer, and then we go to the next frame. So that's what this is what we were doing before to increment the frame, to go through each frame, but we were doing it way too fast. So here we're only going to do it if we hit this frame duration. Now, something I'm not too sure about is the animation timer. I'm not too sure if we're hitting the right time for that. So I'm gonna throw in a print statement to debug here, just so we can see how fast that's moving and what's actually happening there. Okay, right. So it's super slow. So if we're trying to, yeah, I mean, we're trying to get to 100, right? And this is taking a long time before it'll even get to the next frame. So I think, we do need to times it by 1,000 to get to the milliseconds. So here, delta time times 1,000. Okay, that's much better. So here we can see our player moving along. We move to the other way, move to the right, move down, move left, move up. Okay, great. So that seems like it's a nice, good speed for moving around. Obviously, there's a problem, right? Like I'm just tapping the buttons, and he's still moving. We don't want that. We only want the player to animate when it's moving. So we should probably look at that next. So now that we have the animation sorted out, I mean we need to move the player as well. So that's something that we have to do. But let's start with working out whether or not the player is moving, and if the player is moving, then we animate. If the player is not moving, we don't animate. Okay, so just an edit here. So I've looked at the documentation, and the tick function updates the clock, and it returns milliseconds. So in our code here, when we're getting the delta time originally, and we're using the self clock tick, um, dividing by 1,000, that will get us seconds, right? Because it's already in milliseconds. So we can remove that, and we'll get it in milliseconds. And then when we go back up to the update function in the player, we can remove that. So we'll just grab the delta time in milliseconds. We'll work in milliseconds, and then that way, yeah, we're getting the right speed, and we don't need to times it by 1,000, divide it by 1,000 for absolutely no reason. So yes, if in doubt, go to the documentation. It will make things a lot clearer. Let's handle whether or not a player is moving. So we can start off by um, initializing the player and saying self moving equals false. So we start the game, the player is not moving. Then when it comes to our animation, we can say for the animation timer. I mean, we don't need to do any of this actually. Yeah, we don't need to do any of this. So if self moving is false, sorry, no, if self moving, so if the player is moving, that's when we'll do all of this. Yeah, otherwise we won't change the frame or anything. Instead, we'll self frame equals 0. We'll just set it to the first frame for whatever direction it's in. So again, bringing up our sprite sheet here, this will use the first frame of the direction if the player is not moving. So that stops the animation. Then of course we need to handle if they are moving. So here we've got the key presses. So say the keys are being pressed, any of these keys. Then we should set self moving to true. But obviously by default we want it to be false. So because this is a game loop where we go through this, we run this same method every single frame. We're going to have to keep on setting it to false by default. And then anytime a key is being pressed, or anytime it detects a key is pressed, we set moving to true. So I'll just add those in here. Okay, and then let's run that 49. Sorry, that's just else. Oh, okay, sorry. So Python requires capitals for booleans. Okay, great. So here we can see the player isn't moving, but then if I hold the down button, it starts moving. I let go, it stops again. Move to the right, moving, let go, stopped. Stopped. Okay, great. So we have the animation only playing when it needs to. So now we should probably handle movement. We should make the character actually move around the world. Go back to our code, um, and we need to work out where is the part that's actually deciding where this is going to position the player. Now, if you remember back when we put the spreadsheet on the screen, or the player on the screen, we chose to just put it at 0, 0, coordinate 0, 0, the top left. Where was that again? That was here. Whoops, where we're drawing. So this is now under the player class and in the draw method, and we're just giving it a 0, 0 here. So we really should update this to use a vector 2. So here in the Pygame documentation, vector 2. Okay, so I think I'm hoping we can use this in there. Let's see. Let's chuck it in. So, oops, visual mode. So vector, so Pygame vector 2. Okay, nice. Okay, so that's going to be usable. So what we want to do is initialize the player position. Let's just call it position and give that a vector 2, and we'll start with 0, 0, and then down here where we blit the player to the screen, we can give this self position. Okay, let's double check this works. Vector 2, okay, sorry. This needs to be Pygame vector 2. Okay, great. So that's all good. We can use it that way. Let's start off when we initialize this player. Let's start off by chucking them in the middle of the screen. So we can use this screen width and screen height. So screen height divided by 2, screen width divided by 2. Let's see, does that work? No, maybe I've got it the wrong way around. That's better. Okay, so we start off with the player in the middle of the screen, and then let's move them from there. So, whoops, need to close that. So we handle the keys here, and we can change that player position, that vector 2, depending on what keys are pressed. So if we hit the up key, then we'll want to change the x coordinate, the y coordinate, by a certain amount, and that's where we're going to have to work out as well what is the player speed. So let's create another constant here. Let's give it 100 as well. I think that's what, 100 pixels a second. I'm not too sure. And then we can modify the player based on that. So the other thing is though, we're going to have to also pass in delta time here so that we can use delta time instead of just going with the frame rate. So that means we need to pass it into this handle events, and that will be required on the game class as well. So here, handle events, we'll just pass in delta time there as well. Okay, so the keys. So in the player class, handle events, here we can adjust the player based on the keys. So we've got the direction is up. They're now moving. So self position. And what we want to change, I think, is the y coordinate. And we want to remove. We want to decrease that number by the player speed. I think that's what we called it. Yes, player speed, and then times delta time. Whereas when we go down, we want to do self position dot y plus plus equals and minus equals player speed times delta time. Let's just see how this goes. Oh, okay. Okay. Well, we got a typo there. We've got a typo there, but it looks like it might have crashed as well. So yeah, okay. Let's fix this typo first of all. Okay, yeah. So we do have a typo, but we also have a big crash. The fact that the player has just jumped off the screen or just disappeared suggests to me that I've got something wrong with my my pluses and minuses here. So let's print out as a way of debugging our self position, just so we can see what's happening there. Okay, so start off there, hit up. Oh, okay, so that jumps by a huge amount. Yeah, okay. So that's way too much. So this might have to be delta time divided by 1,000 here. Okay, this is much better. Okay, yeah, this is way better. Okay, so the player still feels a little bit slow. I might bump up that speed. But that's much better. That's what we're going for. So let's just bump up the player speed to 150. And then we can fill out the rest of the keys. So when we're going left and right, so here this is going to be self position X. So left, we're going to want to minus, I think, minus equals player speed times delta time divided by 1,000. And here self position x plus equals player speed times delta time divided by 1,000. Okay, yeah, this speed's a bit better, and the player's moving nicer as well. So yeah, so okay, now we do have an issue where we can't move diagonally. I'm pushing both at the same time and it won't let me. So we can look at that. We can look at changing both the x and y coordinates at the same time. I mean, okay, let's just quickly do that now. Well, sorry. I'm just going to remove this print statement as well. Okay, so we should be able to. So here we have else if statements, but they can be done at the same time. So if we just have a collection of if statements, now the weird thing is going to be if you're holding up and down at the same time, then that's kind of silly. But I mean, if you do that, then you just stay in the one place, or you're slightly going to be on one more than the other. So left and right. So you should be able to hold both up and right at the same time, and that'll move you in the diagonal direction. So left, up, and then both at the same time, and we go in the diagonal direction. So yeah. Now we do have the slight sort of bug, slight weirdness of, oh, maybe it's not too bad. Yeah. Yeah, I mean it. I think we have that bug where it is slightly faster if you move diagonally. So maybe we can look at addressing that. But right now, I mean, we've come a long way, right? Like we've got this animating. He's moving around and changing direction. If we stop, he stops. So we've come a long way, and I think we've made a lot of good progress here. I think in future episodes, let's do things like collision detection. We'll build a whole map around this. We'll build a whole game. This is just a small part doing the sprite animation. So yeah, subscribe if you're enjoying this. I'll put out more videos. Leave comments in the description of what do you want to build. What do you want to build? Let's build something together. And yeah, see you in the next video.